Hello everyone, welcome to today's video on volume of prism problems. So we're going to be dealing with volume of three-dimensional shapes called prisms, a type of three-dimensional shape called a prism. I'm going to have Math Antics introduce the concept of volume to you.
In this lesson, we're going to learn about another important geometry quantity called volume. Specifically, we're going to learn what volume is and what kind of units we use to measure volume and how we can calculate the volumes of a few simple geometric shapes.
All of those.
The first thing you need to know is that volume is a quantity that all three-dimensional objects have. But to understand what it means, it will help if we back up just a little and start out with a one-dimensional object, like this line segment. To measure a one-dimensional object, we need a one-dimensional quantity, which we usually call length. The length of this line happens to be exactly 1 centimeter, which is a common unit for measuring length. And in the Math Antics video about area, we saw that if we move or extend this one-dimensional line in a direction perpendicular to it by a distance of 1 centimeter, it forms a two-dimensional object called a square. Two-dimensional objects are measured by the two-dimensional quantity that we call area. Because the original line was 1 centimeter long, and we extended it a distance of 1 centimeter, the amount of area that this square occupies is 1 square centimeter, which is a common unit for measuring area. Okay, now imagine that we take that two-dimensional square and move or extend it in a direction perpendicular to its surface by a distance of 1 centimeter. It forms a three-dimensional object that's called a cube. And to measure a three-dimensional object like this, we use a three-dimensional quantity called volume. Volume tells us how much three-dimensional space, or 3D space, an object occupies. Alright, but how much volume does this cube have? Well, since it was made by extending 1 square centimeter, a distance of 1 centimeter in the third dimension, we say that its volume is exactly 1 cubic centimeter, which is a common unit for measuring volume. So square units are used to measure area, and cubic units are used to measure volume. Since square units are made by multiplying two one-dimensional units together, like centimeter times centimeter, we can abbreviate them using the exponent notation, centimeters to the second power, or centimeters squared. And since cubic units are made by multiplying three one-dimensional units together, like centimeter times centimeter times centimeter, we can abbreviate them using exponent notation, centimeters to the third power, or centimeters cubed. Okay, so volume is a 3D quantity for measuring 3D objects. But since we've also talked a lot about area in this video, I want to point out that 3D objects also have a type of area that you don't want to confuse with volume. You might remember from our previous videos that 2D shapes have both a 2D quantity called area and a 1D quantity called perimeter. Well, in a similar way, 3D objects have both a 3D quantity called volume and a 2D quantity called surface area. Surface area is a lot like it sounds. It's the area of the object's outer surface or shell. Perimeter and surface area are both outer boundaries of geometric shapes. Perimeter is the one-dimensional outer boundary of a two-dimensional shape, and surface area is the two-dimensional outer boundary of a three-dimensional shape. And to help you see the difference between surface area and volume, imagine that you have a perfectly thin box filled with ice. If you unfold the box, you can see the 2D area that surrounds the volume, while the volume itself is the amount of 3D space occupied by the ice inside the box.
So in this case, the box, that's our surface area, right? So when we split it out, when we break it apart, it's flat. So surface area is ultimately two-dimensional, it's just flat. But then the ice on the inside is our volume. That's three-dimensional. Everything that's inside all of the three-dimensional space that's within our box. Okay? Now we're going to look at a little model that might help us discover and understand the formula for the volume of prisms. For this model, we're just going to be looking at a rectangular prism. Okay, so a prism, as we have seen before, is a solid three-dimensional object with two identical ends, or bases, and then flat sides. And the shape of the ends gives it the name, so you can have a triangular prism, a rectangular prism, a square prism, a hexagonal prism, all that kind of stuff. Okay, so we're just going to be looking at a rectangular prism here to try to get a sense of how we find our volume. So if I look, what I have right now, I only have a two-dimensional shape because I have no height. So I have a length and a width, 3 feet and 4 feet. Okay, I can find the area of this shape easily. That's going to be 12 feet squared because I'm multiplying the length 3 and the width of 4, 3 and 4 feet. Okay, so this is two-dimensional. I can just have area, and then I could find the perimeter if I wanted to. But now we need to make it three-dimensional, so we're going to add a height. First, I'll just add a height of 1 foot. Okay, so now if I'm looking at this, I want to find the volume. That's really saying how many cubic units are in this. So I can count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 cubes in there. Okay, so that would mean that my volume is 12 feet cubed. So it might seem like nothing's really changed if you just think about the numbers here, but the difference between 12 feet squared, which is two-dimensional, and 12 feet cubed, three-dimensional, is pretty different, right? It's a difference between like someone of like a piece of paper in a box. And then we're going to change the height. So now if I have a height of 2 feet, now let's try to find the volume. So now I have 12 feet cubed on like the top row, and then I have another 12 feet cubed on the bottom row. So in total here, I have 24 feet cubed. Let's notice that if I do 3 times 4 is 12, times 2 is going to give me 24. Okay, let's continue. So now if I have a height of 3, I'm having 12 on the top row, 12 feet cubed on the middle row, and 12 feet cubed on the bottom row. So thus, overall, I have 36 feet cubed. That would be my volume. That's the number of cubic feet I have in this. Okay, so then if I go up to 9, at a height of 9 feet, I can find the volume. Again, I'm going to have 3 times 4 feet. That's my base. That's that 12, and then I have 9 rows of them. So I'm going to do 12 times 9, that is 108. So that means my volume of this shape would be 108 feet cubed. Okay, so that's going to bring us into our definition of volume for prisms. The definition of volume for a prism for all types, this is a little bit of a general formula, is the area of the base of the prism times the height, or sometimes that's called like the length extended. So if I think about this situation, that is my two-dimensional base, my shape of a rectangle, and I found the area of that. That area is 12 feet squared. And then I multiplied that by my height, however much I extended it in feet, and that always gave me my volume. So that's going to be the case, whether we have a triangular base, or a hexagonal base, or a square base. In any version of that, I'm going to find my area of my base of that prism and then multiply by my height. Okay, so let's look at example 1. So example 1 says find the volume of the triangular prism. So if I see here, I have a triangular prism. I have this triangle, that is one base, and this triangle, that is another base. And these are truly like the whole triangle. I'm thinking really here about those areas. Okay, so I need to find the area of one of those bases and then multiply by the height. In green here, I need to find the area of a triangle because I have a triangular base. So to find the area of a triangle, we said we multiply 1/2 times the base of the triangle, and then we multiply by the height of that triangle. Now this is confusing because we have a big B, which is the area of the base, and then little b, which just kind of meant that length of the bottom of our triangle. So that's confusing. And then again, you also have this height, which is talking about within the triangle, which is different than the height of the prism or the length extended. So it's confusing. But if you can look past the letters, I think the concept is what matters, and I think that's what normally works for people. And then I'm going to multiply again times my height of my entire prism. Okay, so I have 1/2, and then I need to multiply by the base of the triangle. So the base of the triangle here is 6, and then the height of the triangle is going to be 4. Okay, and then I'm going to ultimately end up multiplying by the height of the prism, or like that length extended, right? So if I think about back to this, the height of my prism, when I'm extending that upwards, that length is going to be this 10 right here, right? It's extended a length of 10 units. So I'm going to then multiply by 10. Okay, so for my area of the base, I have 1/2 times 6 times 4. 1/2 of 6 is 3, and then 3 times 4 is 12. So that means that the area of this triangle is 12 units squared. And then I need to multiply that area of the base times 10, my height of the entire prism, or my length extended. And when I do that, what is 12 times 10? Yep, 12 times 10 is 120. That's my final answer, is going to be 120 units cubed. Okay, we're going to look at now a little bit more of an application example. So for our second example, this one's going to be a little bit more challenging. It's a word problem. A cheese box is shaped like a right triangular prism, just like we just worked with. Great. The box is 6 inches long, 4 inches tall, and has a volume of 24 cubic inches. Can a cube of a cheese that's 2 inches on each side fit inside the box? We are missing what I would end up calling the height in this example, that like length extended. Really, this question comes down to, we're given the length, the width, and we need to find the height of this triangular prism, and then we'll answer a question based off of that. So just like before, we're going to use this volume of a prism formula. Are we told, let's go through each variable, are we told the volume of this prism? And has a volume of 24 cubic inches. Yes, we are. So great. Okay, so V is 24 cubic inches, so I can substitute in 24 for V. Okay, then B, big B, are we told the area of the base? Well, we're not explicitly told the area of the base. So that triangle is my base. So we know that the formula for the area of a triangle is 1/2 little base times height of the triangle. And then eventually we're going to multiply that by the height, or that length extended, of the prism. Okay, so looking at the area of the base, are we given our triangle's height? Yes, we are. The triangle's height is 4. Are we given the base, or that length across, of this triangle? Yeah, it's 6, right? That's the base of the triangle. So thus, I can very easily find the area of the base of my triangle. Okay? Am I given the height of the prism? No. But that's good. That's the only missing piece of information. That's what we said we were trying to find. Okay, so let's try to simplify these sides. Okay, so 1/2 times 6 is 3. Half of 6 is 3. And 3 times 4 is 12. So we're going to get, just like last time actually, the area of this triangle's base is 12 units squared. And then that 12 is getting multiplied by my height. Because to find the volume, I multiply the area of the base, which is 12, times the height, which is what I'm trying to figure out. Okay, so now I have an equation, a one-step equation involving multiplication. So just like always, I'm going to ask myself, what is currently happening to my variable? What is currently happening to h? H is being multiplied by 12. So, how do you undo multiplying by 12? Dividing by 12. Awesome. Okay, so then to both sides of my equation, I'm going to divide by 12. 12 divided by 12 goes away because it's equal to 1. Any number divided by itself is 1. And then I have 24 divided by 12 is equal to 2. So my height then, this value right here, that height, or that length extended, has to be 2, and we're talking about inches here, inches. The height of this triangular prism box is 2 inches. So can a cube of cheese that's 2.5 inches on each side fit inside the box? No, because if it's 2.5 inches, it's not going to fit in a box that's smaller than that. So since we figured out the height of the triangular prism box is 2 inches, the cheese isn't going to fit inside of it. So in this video, we ended up really just looking at the volume of triangular prisms directly. But when we looked here, this was the volume of a rectangular prism, where to find the area of the base, you don't have to multiply by 1/2 or anything. You're just multiplying base times height, because that's how we find the area of a rectangle. All right, great. Good job, everyone.